So what if you could have a perfect virtual copy of, well, anything in the real world? And I mean a copy that lives, breathes, and changes right along with the real thing. It sounds like something straight out of science fiction, right? Well, it's not. It's a technology called the digital twin. And today, we're going to break down how it's already changing, well, everything. Let's just start with a couple of what-if scenarios to get your mind going. What if a bridge could literally send you an alert that it's developing a stress crack long before it ever becomes a danger? Or what if a jet engine could tell you, hey, I'm going to need a new turbine blade in about 50 flight hours? This incredible predictive power, that's the promise of the technology we're talking about today.
So what exactly is it? At its simplest, a digital twin is a virtual model of a real-world thing. But here's the magic, the part that makes it revolutionary. It's connected. It's constantly being fed a live stream of data from sensors on its physical counterpart. So you have to understand, this isn't just some static 3D model. It's a living, breathing, dynamic reflection of the real thing in real time.
And you know, if you look at any of the official definitions, you'll see one theme over and over again. That live data link is everything. It's the secret sauce. Without that constant, real-time feedback loop, you've just got a model, not a true twin. That connection is what gives it the power to actually emulate, to predict, and ultimately to optimize what's happening in the physical world.
Now, while the name digital twin feels super modern, the basic idea has a really cool history. It actually goes all the way back to the 1960s. NASA used these early physical simulators, you can think of them as analog twins, to figure out how to save the Apollo 13 mission. The idea was later explored in a 1991 book called Mirror Worlds, but it was NASA, again, in 2010, that really gave us the modern, practical definition that we all use today.
Okay, so we've got the what and the why. But how does one of these things actually work? Well, it really boils down to three essential parts.
First, you have to have the physical asset in the real world. This could be anything, a single wind turbine or an entire factory. Then you build a super detailed digital model of that thing. And finally, and this is the most important part, you connect the two with what engineers call the digital thread. That's it. That's the constant two-way stream of data from sensors that brings the whole system to life.
Now, something that's really important to get is that not all twins are the same. They're not all created equal. They actually evolve and serve different jobs throughout a product's entire life cycle. From the moment it's just an idea, all the way to its performance out in the real world.
You can really think of it in three stages. First up is the digital twin prototype, or DTP. This is a virtual model of a product before it even exists. Engineers use it to simulate everything and perfect the design. Then, once the product is actually built, you get the digital twin instance, or DTI. This is a twin of one specific item out in the field, monitoring its own unique performance. And finally, there's the digital twin aggregate, or DTA, which is amazing. It gathers data from all the individual instances to learn from the entire fleet and make future designs even better.
All right, that's enough of the theory. Let's get to the fun stuff. Let's look at some of the truly mind-blowing ways digital twins are being used out in the wild right now.
Okay, in manufacturing, this tech is an absolute game changer. I mean it. Companies can create a digital twin of an entire factory floor before they've even bought a single machine. They can run endless simulations, find all the bottlenecks, and perfect the workflow. All of that happens before one physical piece of equipment is even ordered. The amount of time and money that saves is just incredible.
Now, here's a really crucial difference you need to know. You might hear people talk about a digital shadow. A shadow is when data only flows one way, from the physical thing to the digital model. It can monitor. A true digital twin, on the other hand, has a two-way data flow. The digital model can also send commands back to the physical object. It doesn't just monitor, it can monitor and control. That's a huge difference.
And the financial impact of doing this right can be just staggering. Get this, Sheremetyevo International Airport. They implemented a digital twin to manage all of their operations, from baggage handling to plane movements. And they ended up saving over $120 million US. That's not just an improvement, that's a total transformation.
But the impact isn't just about money. It's getting incredibly personal. In healthcare, for example, data from an MRI scan can be used to create a digital twin of a patient's heart or another organ. This allows surgeons to literally plan and even practice a complex procedure in a totally risk-free virtual space before they ever make a single incision.
And it's not just about building the future. Digital twins are also helping us preserve our past. Using incredibly detailed 3D scanning, we can create perfect digital records of priceless historical artifacts, like this amazing temple chariot. It basically ensures they can be studied and admired for generations to come, completely safe from the wear and tear of the real world.
Honestly, the applications are just exploding everywhere. We see them in smart cities, being used to manage traffic and energy grids. They're in construction, monitoring the health of bridges. They're being used to squeeze every last drop of efficiency out of wind farms. They're even in cars, analyzing data from an entire fleet to build safer vehicles. The scope is just massive.
So, where is all of this going? What's the end game for all this digital mirroring? What's the ultimate goal of building these incredibly complex virtual worlds?
At its very heart, it really comes down to this, using data from the here and now to ask incredibly powerful questions about the future. The whole point, the ultimate purpose of a digital twin, is to simulate what could happen, to predict problems before they ever occur, and to optimize performance in a way we've just never been able to do before.
And this all leads us to a final, really profound question. As this technology gets more and more advanced, as we get closer to being able to create a digital twin of an actual human being, well, we run into some huge ethical questions. Who owns all that deeply personal data? And maybe more importantly, what happens when that digital twin predicts a future like a serious medical condition that maybe, just maybe, we don't want to see?